Hi guys! So today we are going to focus on naming acids and then writing formulas for acids. Now you have been kind of naming and writing formulas for acids for a while. We just now need to differentiate the name in between an acid and then just the normal compound ionic name that you would typically write. So very simply, I have attached also a copy of the notes that I am going off of. I've attached them to your blog. So if you would print those out or write them down, they look like this. It says acid naming notes. It's just one page. So if you would look at those, then that can kind of help guide you. And it also lists off all the rules that you're going to need to name these acids. So to start off with, let's just talk about what an acid is. So very simply is that an acid is a compound that releases hydrogen ions when it's in water. And that is basically it. So an acid is a compound that contains hydrogen, and this compound is going to release these hydrogen ions once it's in water. That is it. That is an acid. Now, there are two types of acids that we're going to be naming. One type is called binary, and then the second type is called an oxyacid. You've already heard binary before. You know that binary, or bi means two. So in a binary acid, we're just going to have two elements or two atoms. One of them has to be hydrogen, so then the other one is going to be some type of nonmetal. Now, in terms of naming our binary acids, if you would look on your notes where it says number 3 and it says naming acids, it goes into talking about the rules for naming them. So when we want to name a binary acid, for example, let's say I want to name HF. So let's say I want to name HF. Before, how would we have named HF? Before, I could have named this. What do we think? I could have named this hydrogen fluoride. Could have named this hydrogen fluoride. Now, some of you are going to ask the question, why don't we name this hydrogen monofluoride? Because an acid releases hydrogen ions in water, all of the acids are going to be named based on ionic compound rules, because technically these are two nonmetals. But hydrogen, in this case, can act like it has a +1 charge, and fluorine can act like it has a -1 charge. So technically when we're naming acids, we're really still naming ionic compounds. So just for clarification, okay? So if I look at HF, we would have just said that this is hydrogen fluoride, no big deal. But now we want to give it the acid name. So when we name a binary acid, we're going to find a root word. So I want to add the word hydro, I want to find a root word, and then I'm always going to add the suffix -ic. So HF is going to be hydro. Now I know that this is fluorine, so I want to try to find some like root word here. So fluorine, let's drop that I and E and let's just say fluor. So I'm going to say hydro, fluor, and then I'm always going to end it in -ic. So you have three parts here. Hydro, fluor, -ic. So three parts. Hydro, fluor, -ic. Hydro is your prefix that you will always start out with. So hydro is my prefix. Fluor, that's just the root. So I know that I have a hydrogen and it's bonded with fluorine. So that fluor is telling me that I have H and an F. So I have my prefix, I have my root, and I have the suffix, which is always going to be -ic when we're thinking about a binary acid. Hydro, fluor, -ic, and then I'm going to say acid. So I would name this hydrofluoric acid. Let's look at another one. HBr. So I have H and then I have Br. There's two elements present there. There's hydrogen and there's bromine. We could have named HBr hydrogen bromide. Same thing. But I want the acid name for this. So if I look at the acid name, I'm always going to have hydro because that takes care of the hydrogen part. So let's say hydro. Now I want to find the root for Br. So I know Br is bromine. So a root for bromine could be brome. So hydro, brome. So there's my root. And now I need to add the suffix, which is always going to be for a binary acid, -ic. So I'm going to call this hydrobromic acid. So I have hydrobromic acid. Hydrobromic acid. Okay? Let's do another one. What if we did HCl? So let's do HCl. So I have HCl. Before we could have named this hydrogen chloride, but I want the acid name. So I know this is binary because I have 1, 2 elements. So I have hydrogen, I have chlorine. So you try to name this one. How would I name this? Remember that I'm always going to start with hydro. It's always going to end in -ic. And that middle part is going to be the root. So I would name this hydrochloric acid. Hydrochloric acid. So I have the hydro, I have the root, which is chlor, and then I added an -ic. So hydrochloric acid. Let's do another one. Okay, my next one, I have H2S. So if I look at H2S, I see that I have hydrogen and I have sulfur. So this would be an acid. I could have named this hydrogen sulfide, but instead I want the acid name. So how would I name this one? I'm going to add hydro to start off with. I have sulfur, so I'm just going to say hydro, sulfur, add the -ic. So hydro, sulfur, there's my root, -ic, and then acid. So that gives me hydrosulfuric acid. One more. Let's do H3P. H3P. So we could have called this hydrogen phosphide, but I want the acid name again. So I want to try to name H3P. So try to name this one for me. If you said that this was hydrophosphoric acid, you were perfect. So hydro always starts with hydro. Try to find the root for phosphorus, so I'm just going to say phosphor, and then -ic, hydrophosphoric acid would be H3P. Okay, so that's how we name binary acids or binary compounds for acids. Now we need to think about the other one, which is called an oxyacid. Now, an oxyacid, if you think of the word oxy, you have O-X-Y. Immediately that should make you think of what element? Oxygen. So this means that it's an acid that contains oxygen. So an oxyacid is just some acid, some compound that has hydrogen, and it's going to be attached to a polyatomic ion. So oxyacid means hydrogen attached to a polyatomic, and that polyatomic has to include some type of oxygen in it. So let's say, for example, we have H3PO4. H3PO4. Before, we could have named this hydrogen. What's PO4? You should be saying phosphate. So I could have named this hydrogen phosphate. But we want to name this as an acid now. So H3PO4 could have been named hydrogen phosphate, but let's name it as an acid. Naming the oxyacids are a little different than naming binary acids. Now, we will never, when we name an oxyacid, include the name hydro. Now, instead, we're going to change the ending on your polyatomic ion. So, phosphate ends in ATE. So anytime the suffix of a polyatomic ends in -ate, we're going to change that to where it will end in -ic. So 8, in terms of the polyatomic ion's last name. So phosphate, any ate is going to change to an ick. Any ite is going to change to an us. So we have ate is going to change into ick, and ite is going to change into us. So for example, we had hydrogen phosphate. I would change this to where I'm not going to include hydrogen or hydro. I'm just going to call this phosphoric acid. I would call this phosphoric acid. So I'm changing this PO4 from phosphate to phosphoric. This ick tells me that the polyatomic ending is 8, which tells me it's PO4. Let's look at how H3PO3 would be different, because H3PO3, so this would be, PO3 is phosphite. So before we would have named this just hydrogen phosphite. Hydrogen phosphite. So I'm going to look at this ending here, and that ending is ite. So what do? We're going to change this ite to an us. So instead of hydrogen phosphite, I'm going to call this phosphorus acid. So this becomes phosphorus acid. So if it ends in an ite, we're changing it to us. If it ends in an ate, we're changing it to ick. And make sure you have the acid following whatever word you've just changed. Let's do some more examples of these. Let's say we have HNO3 versus HNO2. So NO3, you know, is nitrate. NO2 is nitrite. So I have, before we could have named this hydrogen nitrate, this would have been hydrogen nitrite. So if this is nitrate, so we had hydrogen nitrate. I want to change that to the acid name. So nitrate ends in ate. I want to change that to an ick. So instead of nitrate, I'm going to call this nitric acid. So because it ended in ate, I'm going to change it to an ick. So this becomes nitric acid. So now let's do the same thing for HNO2. HNO2 was hydrogen nitrite, but now I need to change that to where it's in its acid's name. So for the acid name, this ends in ite. That means it's going to change to us. So I'm not going to call this nitric acid. I'm going to call this nitrous acid. Okay, so we have nitric, nitrous. You got it. What about if we did hydrogen carbonate? That's a good one. How about H2CO3? So on this one, I have H2CO3. So we know that this is hydrogen carbonate. So I'm really just looking at that carbonate. Carbonate ends in ATE or ITE. You should be saying ATE. So I have carbonate. That means it's going to change from ate to ick. So I'm going to call this carbonic acid. So this was hydrogen carbonate. I look at that carbonate. It ended in ATE. That means that the ATE turns into ick. So I'm going to call this carbonic acid. Should we do one more? I think we should do one more. What if we did, let's do H2SO4. You try this one on your own. H2SO4. So before we would have called this hydrogen sulfate. So sulfate. How would we name this now? I'm going to change that 8 to an ick. So I would call this sulfuric acid. Sulfuric acid. Okay. Tomorrow, guys, we're going to go through some more examples of these, but I at least wanted to introduce you into naming these compounds or naming acids. So just remember that an acid is something that will release hydrogen ions once it's dissolved in water. And there are two types. There's binary and there's